Hello viewers, I'm Kausalya. Today we are going to solve problems in exercise 12.3. Problem number 3. Find the area of the shaded region in figure if ABCD is a square of side 14 cm and APD and BPC are semicircles. So here you see we are having a square, right? And whose side is 14 centimeters, right? So we have to find this shaded part. You see, when you look at this diagram, you see we are having a square and these two are the semicircles. So how to find the area of this shaded region? First, you have to find the area of the entire square and you have to subtract the area of these two semicircles from it. Right. So here I am drawing the diagram of the semicircle separately. So to this semicircle, what is this? This is the diameter, right? And its value is 14 centimeter. So what about the radius? It is diameter divided by 2, which is 7 centimeter. So next we are going to write down the statement. So area of the shaded region is area of the square minus area of the two semicircles. So here what is the area of the square? It is nothing but a square, right? That is side. So here the side is 14 centimeter. So 14 into 14 minus, here we are going to find area of the two semicircles. So area of a semicircle is given by pi r square by 2. Since we are having two semicircles, I have multiplied by 2 here. Because you see the two semicircles are similar, right? Because they are having the same diameter and they are enclosed in a square. And when you look at this diagram, it is clear that the two semicircles have similar area. So here I am multiplying by 2. So this 2 and 2 cancel each other. So here we will be having pi r square. So 14 square is 196 and here this pi is 22 by 7. And what about the radius? We have already calculated, it is 7. So 7 into 7. So finally 22 into 7 gives 154 and here the final answer is 42 centimeters square. Right, so this is the area of the shaded region. So now problem number 4. Find the area of the shaded region in figure. So here the shaded region, it covers all the things. Right, we have to find the area of the shaded region where a circular arc of radius 6 centimeter. So here we are having a circular arc whose radius is 6 centimeter has been drawn with vertex O of an equilateral triangle OAB of side 12 centimeter as center. Right. So here the diagram is given to you. Right. So don't get much more confused with the question. So here the radius of the circle is clearly mentioned as 6. So obviously this is the radius, right? And here we are given with an equilateral triangle, right? This is an equilateral triangle whose side is given by 12 centimeter. So what is an equilateral triangle? A triangle whose all the three sides are equal. Right, when a triangle has equal values in all the three sides, then it is known as equilateral triangle. So here we have to find this value, right? So area of the triangle is easily calculated, right? Yes or no? Yes. So area of the triangle is easily calculated, and that too for equilateral triangle we have a special formula to calculate the area, right? So first we will start with that. So area of the circle is root 3 by 4 into a square, that is side square. So what is the value of side? It is 12 centimeters. So just substitute the value. So here finally it is 36 root 3 centimeters square. So this is the area of the equilateral triangle, right? And here now we have to find area of this part, right? So how can we call this part? You see it is enclosed by 2 radii, that is I'll draw separately. So here we have to find the area of this portion. So obviously we can call this as a sector because here we are having 2 radii and the corresponding arc between them, right? So what is the formula to calculate the area of the major sector? So here the formula is 360 minus theta by 360 into pi r square. Right. So how to find the value of theta here? Because no value of theta is given. So in this case, you have to consider the properties of equilateral triangle. Right. So what is the value of angle in an equilateral triangle? It is 60 degrees. Right. Each angle is 60 degree. That is the property of equilateral triangle. So here obviously here the angle is 60 degree. So how to calculate the remaining angle here? How can we calculate the remaining part over here? Because the angle enclosed by a closed path is, it is 360 degree. Right. Now I want the angle of this part. So here I am having 60. So when you subtract this 60, then obviously we will be getting the angle value of this sector. Right. So here the theta is 60. So just substitute the value here. 360 minus 60 by 360 into pi r square. So again, that is 360 minus 60 is 300. The value of pi is 22 by 7. And what about the value of r? The value of r is 6. It is clearly given in the problem. Right. The value of r is 6. You see? A circular arc of radius 6 centimeter. So just substitute the value of 6 over there. Right. And again, 0, 0 cancels and 30 and 36 are cancelled by 3. So here I am getting 10 by 12. So 10 by 12 into 22 by 7 into 6 into 6. So obviously you see 6 and 12 2 times and 2 and 22 11 times. So the remaining terms are 10 into 11 into 6 by 7. So again when you simplify here I am getting the value as 660 by 7 centimeter square. Right. So what is the question which is asked here? You have to find the area of the entire part. Okay, area of the shaded portion. So what is the area? Here we had calculated the area of the sector as well as the area of the triangle. So finally you have to add these two areas. Right, that's it. So when you add, you see area of the shaded region is given by 36 root 3 plus 660 by 7 centimeter square. Right. So we will proceed with our next problem. Problem number 5. From each corner of a square of side 4 centimeter, right, a quadrant of a circle of radius 1 centimeter is cut, and also a circle of diameter 2 centimeter is cut as shown in figure. So here we are having a square, right? And you see there is a circle of diameter 2 centimeter. So this is the circle, diameter is 2 centimeter. And from each corner of a square, right, a quadrant of a circle of radius 1 centimeter is cut. That is, from each corner we are drawing a quadrant whose radius is 1 centimeter. Right. So here you see we are having 4 quadrants whose radius is 1 centimeter. Right. So find the area of the remaining portion of the square. So here the thing is, you have to find the area of all these 4 quadrants. Right. And you have to find the area of the circle. Then you have to subtract these two values from the area of the square. Right. So here the side of the square is, it is given as 4 centimeters. Right. So area of the circle, that is finding the area of this center circle is easy because you know the dia. So you can calculate radius, then you can find the area. How to find the area of these quadrants? Right. So here I am going to tell you a shortcut. You see, a circle has how many quadrants? Obviously a circle has 4 quadrants. Right. Now we are having 4 quadrants here. Right. How the 4 quadrants are, you see, here is 1 quadrant, here is 1 quadrant, and here is 1 and here is 1. Right. Now we are going to take this in reverse. Right. These 4 quadrants together forms a circle. Say yes or no? Obviously it is yes, because here the radius of all the quadrants remain the same. Right. Therefore, these four quadrants when combined together, they will form a circle. Right. So it will be pretty easier for you. So here in this case, what is the area of the circle? It is given by pi r square. What about the radius of this quadrant? It is obviously 1. So just substitute the value of r as 1, then the problem is solved. Right. So here you see four quadrants together form a circle. Okay, just now as I explained, right? So we are making these four quadrants as a circle, single circle, right? So area of the circle is pi r square, and obviously the radius is 1. This is given in the problem. So area is pi into 1 square, which is pi centimeter square, right? So let this be your equation 1. Now we are going to find the area of this circle. So here area of the circle is given by pi r square, and again the diameter is 2, therefore the radius is 1. So it becomes pi centimeter square. Now what about the total area? You can write total area of circle and four quadrants. Right. Total area of the circle and quadrants are area of the circle is pi centimeter square and area of the circle at the center is pi, again pi, right? So we are combining, we are adding 1 plus 2. So that gives pi plus pi, which is equal to 2 pi centimeter square. Fine. Now we are going to find area of the square. The formula is a square. So what is the value of side of the square? It is 4 centimeter. So 4 into 4 becomes 16, right? Therefore the remaining area of the square is given by area of the square, which is 16 minus area of the circles and circle plus quadrant, right? So 16 minus this combination is 2 pi here. So 16 minus 2 pi, and the value of pi is 22 by 7. So 2 into 22 becomes 44, right? The next step is we are going to take LCM. So 16 by 1. So here 7, here 7. So 16 into 7 minus 44 divided by 7. So here this becomes 112 minus 44 by 7, which is equal to 68 by 7 centimeter square. Right, again we are going to find the area. So here the unit is centimeter square. Right, so that's all. If you have any doubt, let me know in the comment section. Thank you.